In this lesson, we're going to talk about slope. And so this is part one of our slope lesson. We'll have this lesson in two parts. So the first part, we're really just talking about what slope is and the basics of how to find a slope. So slope will often be referred to as the rise over the run. That's what this is here, rise over run, where we're actually creating a fraction or a ratio between how far we're moving vertically versus how far we're moving horizontally. So the higher that ratio is, the steeper your object is, or the steeper that slope will be. So slope really describes the steepness of an object like a hill or stairs, as you see in these examples here, and what we'll be getting into, the steepness of lines. So when we're discussing slope, you might think of things such as roads, ramps, roofs. Anything with an incline or decline has a slope, and so mathematically we can represent that incline or decline using slope to explain that steepness. So, as we said, slope is that rise over the run. So to calculate a slope of an incline or decline, we can count the rise and divide it by the run. So the rise refers to your, oh, I'm ahead of myself. So the rise, if you rise up, so rise refers to your up and down movement. So if you rise up, your rise would be a positive value. And this should make sense mathematically because if we think of moving up on a coordinate grid, this is in the positive direction. If you rise down, so if you go down for your rise, you're moving in the negative direction. That would be a negative value. If you run, so running refers to the horizontal movement from side to side. If you run in the positive direction, that will be to the right. And if you run to the left, that makes a negative run, so a negative value for your run. We will also always make sure to reduce. So if we're finding the slope of this roof, what we'll do is start at one of the points, and I'll show you we can start at either one, but let's say I start here at the point right at the tip of the top of the roof. We would calculate the slope, and we will always move up and down first. So to get to another point on that roof, we would have to rise, in this case, in the downwards direction. And we are told that this is a distance of 8 feet. So we're rising 8 feet down, which means really this is a negative 8 in our rise. Then, so if I'm calculating the rise over the run, we just found the rise was negative 8. Then we look from this point here that we are at, we will run to that next point horizontally. And our run moves to the left 12 feet, making the run negative 12. Finally, we need to make sure to reduce. Negative divided by negative is positive, and we can divide both by 4, making this a slope of 2/3. Like I said, you can actually start at a different point on the roof. Let's say we started here. To calculate the slope, we still would calculate the rise first. So in this case, I would rise up first, and it's the same distance as over there. I would rise up 8 feet because I'm going up, it's positive. And you'll see that will still give us the same slope. And we run this time again a positive slope because, or 12, because we're running to the right. So this time we get positive 8 over 12, which still reduces to that same slope of 2/3. So it does not matter where you start on the line to count your rise and run, as long as you do count rise first and put that in your numerator and run second in your denominator. So let's practice another one. Here we have the skateboarder going down this ramp. So to calculate the slope of the ramp, we will start at one point of that ramp, and we'll rise first. So that in this case would be going down from where I am. If you were starting here, you'd be going up first. But in this case, I'm going down 18, so that's a negative 18. And then I'm running to the right 24, so that's running a positive 24. So this slope is negative, and 18 and 24 both divide and simplify. We can divide them each by 6, giving us 3/4. 3/4. So this has a slope of negative 3/4. Again, if you chose to rise first, starting at this point, you would rise up 18, positive 18, and left 24, negative 24, still reducing to a slope of negative 3/4. So no matter which way you start, we're getting the same slope. We can also calculate the slope of a line on a coordinate grid. And the way we'll do that is we'll use 2 points on the line and count the rise and run using those points. So you'll notice we've been given 2 points that are actually on this line. One of the points is at 2, -1, and the next point is at -2, -4. And we start at either point, just like we've been doing. So let me start at this one here to the right. I'm going to calculate the rise first. So I'm going to rise, in this case going down, until I hit that grid line that matches the next point I'm trying to get to. So in this case, I'm rising down 1, 2, 3 grid lines. So that's a rise of -3 because I went down. Again, counting rise first. And I run -1, 2, 3, 4. I went to the left, so it's negative, which means this slope is a positive 3/4. Again, if you rose this way first, you'd be going up 3, running positive 4. Again, still a slope of 3/4. Why don't you try this one on your own? So pause the video, calculate the slope. When you click play, we'll check our work together. Okay, so for this one, we should have risen, in my case, a -1, and ran a positive 3. The rise was -1, the run was positive 3, so the slope is -1/3. If you started at this point, you would rise up 1, run left 3, which is -3, still giving us a -1/3 slope, right? So we are all getting -1/3. A couple things I want to bring to your attention before I get to part 2 of the video is that we had some slopes that were negative and some that were positive. This is a positive slope. This one was negative. Look at the difference in our lines. Here's a negative slope. There's a positive slope. Hopefully, you can see that negative slopes go down and positive slopes go up from left to right. So this is a negative slope. So I imagine a man at the left side of my line, and we could see in this case he'd be going down this line, making that a negative slope. Over here, our man, if I start him at the left side, would be climbing up the line. It's in a positive direction, going up from left to right, so that's a positive slope. So as you get more comfortable with slopes and being given slopes, you'll notice the sign of the slope will tell you a nice little bit of information about the steepness, well, not so much the steepness, but the direction that that line is falling or rising. So if it's negative, your line's going down. If it's positive, your line is going up. You can see a slope of -1/3 is not as steep as a slope of 3/4, for example. So we talked about in the beginning that that ratio is what tells you the steepness of the line. Okay, and that's part 1 of this slope video.